All right, let's get started. We have an in-class today at the end of class. And I have some stuff that the in-class from 2 weeks ago to hand back while you're doing the in-class today. But today's about preparing for the quiz that's on Monday. Did everybody get the instructions I sent? So everybody knows what's expected of them? I just want to make clear a couple of rules that I want to make sure you saw on that list. One is at the end, when I say time's up, you have to put your pen down. I'm penalizing anybody who keeps going after I say time's up. I'm gonna, for the first 30 seconds, you're losing 1 point, and I think it's gonna be maybe 12 points, so that's losing 8%. Another 30 seconds, you're losing another point. So when time's up, you gotta put the pen down. The other rule is if you're using your own device, laptop or whatever, you can only use one, either the computer that's up here, or you can use your own device, one or the other. You have to have the screen turned up all the way. So make sure you have it charged up before you get here, because it will take you forever to find a plug underneath these desks. I think maybe only one student in the last 3 years has been able to find a plug under there. So they're so hidden underneath there. Or bring an extension cord, because there are plugs against the wall that are easy to find, but not underneath. You got to turn it up all the way. If it's not turned up all the way, it's going to turn into a problem. Huh?
Brightness turned up all
the brightness turned up all the way, so when I'm walking around, I can see it. No previous tests. No notes. What you do is you just take pictures of your notes, email them to yourself, and open them up before the quiz starts. Just take all your notes and make them into pictures. So you can still use all your notes. You just got to turn them into pictures. You can't have the paper in front of you. A student had stuff stuffed in the paper a couple years ago and took that away from everybody from that point on. So you just got to turn it into digital. The only notes you have in front of you is the quiz itself. When you're using Excel on the quiz, it's just like the homework. You open up Excel on your computer, but you're typing in whatever equation you use, you write down that equation, then you write down the result you got off of Excel, just like the homework, showing me exactly what you typed. Here's the number one mistake though that's happening on the homework, and I don't want you to lose points on the quiz. You've got to have the equal sign. I need to see exactly what you typed in, and without that Excel equation doesn't work in Excel. I need to see you typed in exactly what you typed in, which always includes that equal sign. So make sure and include that. I know that during the recorded lectures last year, before I discovered these two, so I think I was using T.INV and T.INV.2T in the lecture, but today I'm going to talk about these two because these two are so much easier, and I'm going to really focus on these two to find the critical value for the rest of the semester. So this is a good one to take a picture of and have in front of you all semester long. And this one's, if you're looking for Z, that number right there is if it's a one-tail problem, you're putting the confidence. If it's a two-tail problem, you're putting the confidence plus half significance. Now let me make something clear. Every problem on this first quiz is two-tailed because confidence intervals are two-tailed. Confidence intervals are always about the middle of the bell curve, leaving those two tails. So every confidence interval is two-tailed. There's no reason to even look at the directions here for one tail for this first quiz. The second quiz, third quiz, final exam, you got to say, okay, is this one tail or two tail? And you're going to learn how to recognize whether it's one tail or two tail. But for now, this first quiz, two tails. You only use confidence plus half significance. Two tails, so you only have to use the significance. Now, you don't have to double it. So that's the rule for this first quiz. If you want to use these. If you want to use the ones that you used on the homework with the 2T or whatever, you feel comfortable with those, use those. That's fine. Whatever you feel more comfortable with, accepting any one of them. But these end up being the ones I'm going to really harp on the most for the rest of the semester. All right, we got those, right? So now, here we go. Get ready. Oh, wait. Whoop. This right here. This is what I want to highlight. We have 3 confidence intervals that we've been learning for these 3 weeks. In the first week, it was all about a mean and the population standard deviation being given. So I'm going to call that number 1. The mean and population standard deviation. The second week was all about the mean and the sample standard deviation. I'm calling that one number 2. And the third week was all about the proportion. Let me add to this, all right? The first week was the mean with the population standard deviation, and it was about a Z. The second week was the mean, the sample standard deviation, and that was all about T. The third week is the proportion, and that's all about Z again. There it is. Those are the only 3 proportions we learned for this first quiz. The only other formulas that you need for the first quiz is to be able to calculate the minimal sample size, which we're going to talk about towards the end of this lecture. And I have both of those formulas right here. If you have to find the sample size for a problem that has a mean, this is the formula. If you have to find the sample size for a problem that has to do with a proportion, this is the formula. So that's it. There's 5 formulas. All right, now, I thought to myself, how am I going to prepare them for this first quiz? Because I want everybody to do well, and you had 2 lectures where you had to watch a recording instead of listening to me. And so, I know it's kind of harder watching a recording compared to being right here and listening to me. Let me also make sure you realize how sick I was. I was so sick. There was a few days where I thought I was fighting for my life. It was bad. It was suffering. And I'm not well yet. But I wanted to be here to make sure you get this information to prepare for this first quiz. And I'm going to be here for the quiz, I hope. I didn't get my appetite back until just 2 days ago. I haven't had a full meal to 2 days ago. But I tell you what, Monday nights, all day yesterday, I'm eating about twice as much food as I usually eat because my appetite's coming back like a storm, which is weird. So I lost over 10 pounds. I don't know if you can see the gauntness of me at all. But I'm going to get it back on because my appetite's like roaring right now. So it will come back, I think. Meanwhile, I'm not myself. So we're just going to hang in there and do the best we can with how I feel. I'm going to bring up some problems right now, just like you're taking a test. And I want to hear if it's number 1, number 2, or number 3. Which formula should you be using? Man, where'd it go? Assume a sample proportion equals 0.60 and a sample size of 50. Construct a 95% confidence interval manually using Excel to find Z or T, blah, 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 blah. Is this number 1, 2, or 3? 3. How do you know it's 3? It doesn't have a standard deviation. Matter of fact, it even mentions the word proportion right there. It doesn't. So if it's number 3, are you going to be using T or Z? You got it. That's the toughest part of this first quiz, is reading the problem and determining which one of these formulas should be using. At this point in time now, this would read that I want you to solve it manually and give me the Excel equation for the critical Z or T, which you just got done telling me is going to be a Z. Here's how it's graded. Is the Excel formula there to find that critical Z? Is the setup, is every number in the formula, let's look at the formula, because you guys just got done telling me this is proportion. So to find the proportion, hang on, I'm almost there. Is that it? There it is. There's the formula, slide 26. Slide 26 is number 3 formula, one of the most important formulas for this first quiz. And this is what, showing me which numbers are in every one of those variables is called the setup. That's where most of the points are. You're looking at a quarter point, quarter point, quarter point, quarter point, quarter point. That's 1, 2, 3, 4, 5. So there's 1.25, probably out of 2.5 or 3 points, just in the setup, showing me you're putting the numbers in the right place. Now there's another half a point, a quarter and a quarter, showing me 2 calculations, just like the homework. Taking that, and maybe you're taking P times 1 minus P. There's a calculation, get a result. Then you're dividing it by the sample size. There's another calculation. I need at least 2 calculations if I'm asking for you to solve it manually. There's another half a point. Then the intervals themselves, the results. That's another half a point, a quarter for each one of those that you got those correct. There's the points. The Excel equation, the setup, 2 calculations, the results. That's all there is to it. Now, don't get confused with a problem that's asking you to solve it using Excel only. That's like on the homework where I'm expecting you to use the Excel equation confidence. There was confidence in week 1, and there was confidence.t in week 2, correct? Those are the ones you use if I said only using Excel to solve it, not solving it manually. I'm looking for those equations. Everybody get it? Yes.
Is there a confidence one for this one or no?
I can't remember. There probably is, but I'm not gonna ask you for it, cause I didn't put it on the homework.
Yeah, that was it.
Yes, right, is it
Well,
on the
we didn't
homework?
have homework for.
Is it on the homework?
We didn't have homework for.
Yeah, we do. I posted already. Week 3, aren't we talking about week 3 homework? Yeah, it's due never, but it's still posted. Yeah, this is your guide to, how to do the problems. You guys gotta make sure and print the answers to each week's homework. Or not print, I'm sorry, open, have them open right in front of you so you can see, because you're gonna realize the problems on the quiz are directly related to the homework. I'm not trying to trick you. And so you can use the homework as guide. I don't think I did one though. Here's number 1 for the homework. We should talk about these, but hang on, let me see number 2. No, number 3. Oh, here I'm asking you for the sample size. And that's it, there's just 3 examples. So that's the sample size, this is a proportion confidence interval, and this is a proportion confidence interval. So there won't be a question that's asking you for this, but week 1 and 2 did have, where I was asking for Excel only, so one was confidence and one was confidence.t.
How many questions is the quiz?
You know, I'm not done writing it. At this point, I'm gonna guess there's gonna be 8 or questions, 9 questions. And out of those 8 or 9, I'm gonna guess there's 3 multiple choice. And the rest are problems like homework. That's what you're expected. And I think the time limit is gonna be about 50 minutes, but it may be a little more, I'm not sure. Go ahead.
Multiple choice,
Multiple choice or what?
like multiple choice from the slide,
From what?
from the slide.
From the slides? Yeah, kinda. I know one multiple choice I wrote is not from the slides though. It's kinda like what we're doing right now, with practicing. It's kinda like it, like just identifying what kind of problem you have type of thing. God, I'm giving away this quiz now. This is too much.
Well, you said to read pages 80 to 89 of the book?
No, don't forget, the instructions will tell you exactly what pages to read for each week. Let me look at this week's instructions, hang on. So for example, week 3, and remember these pages from the book I have, at 295, 301, that's based on the 4th edition. All right, so have you guys figured out a way, are people sharing like a downloaded 4th edition where you can open it up and have that one? If you have a physical 5th edition that you had from 301 or something, you can compare. I don't think the pages are gonna line up though. But I don't think they changed the problems as far as, once you find the problem from chapter 8 in whatever edition you have, if the problem's gonna be the same. But I went ahead and I didn't use problems from the book. I went ahead and wrote my own problems because I was assuming that some people have the 5th edition, some people have the 4th edition, some people have the 3rd edition. So don't forget, you can use your book during the quiz, including a physical book. That's the only paper thing you can have in front of you other than the quiz is a paper book if you have it. What I find interesting about the book is, especially on a multiple choice question, if you see the subject on a multiple choice question, you can go to the back of your book and look up that subject, and then you know what page you go to, and you can quickly go, oh, and that would kind of really help you then answer the multiple choice. That's how I would do it. Okay, let's get to the next one. Whoop, 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 whoop. In a sample of 400, a company finds that has 20 successes. Manually construct a 90% confidence interval for using Excel to find Z or T. Number 1, 2, or 3? 3? I thought the last one was a 3.
1.
Is this a 3? Well, let me ask you this. Why is it a 3? What's the, is there a population standard deviation? Is there a sample standard deviation? No. You know it's 3. If you can say no to both those questions, there's no doubt it has to be 3. I don't see a standard deviation on there at all, so it has to be 3. The only way this could trick you is if it was asking for the sample size. Now that's a whole different equation. It's one of these two then. But this is asking for a confidence interval. It can only be one of 3 equations, and there's no there's no standard deviation there. So there's no way it could be anything but 3. Proportion. Again, the same formula. I want to make sure we set it up. What number, well, let me ask you this. Let me stare at it. Give me the Excel equation I'm going to use to find my critical value for this problem right here. Which one? Which one am I using? The top, bottom, top, bottom? Top? Why? Because I'm looking for Z. It has to be the top one. All right, so what number, is this a 1 tail or 2 tail? has to be two-tailed. It's a confidence interval. There's only two-tailed on the first quiz. No hesitation there. Since you know it's two-tailed, what goes in those parentheses from this problem right here? 0.95. 95. 90% plus half the significance. The significance is the opposite of the confidence, which is 10%. Half of it would be 5%. Add 5% to 90, 0.95. You got it. All right, we're on the right page. Should I talk about the setup? We have to, let's go to the next one. According to a survey, 44% of adults admit keeping, what, did I open the wrong file? I think I opened the wrong file. These are all proportions. All right, hang on, I opened the wrong file. Hang on. All right. Hang on. All right, here we go. Let's figure this one out. In a recent poll of 760 homeowners in the United States, 1 in 5 homeowners report having a home equity loan that he or she is currently paying off. Using confidence coefficient of 0.90, that's the same as a 90% confidence, 0.90, blah, 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 give me the Excel equation for Z or T. Is this 1, 2, 3, or 3? 1, 2, or 3? Again, are you guys serious? Are you serious? This is 3. Because why? There is absolutely no standard deviation in there again. No standard deviation, it has to be 3. All right, instead of giving the Excel at 90%, which we already just talked about what the Excel would be at 90%, instead of that, let's do a quick setup, all right? I'm gonna throw the equation up here. This is it right here, isn't it? Let's do a quick setup. I gotta read it again. Can't remember the numbers. 1 in 5, what is that? 20%, isn't it? 20%. So there's our, is that our P then? Our given proportion is 20%. And what other number we need? Well, what's our sample size? 760. So it's going to be, what did I say, 20%? 0.20 plus or minus our critical Z. I'm just going to put Z right now because we haven't calculated it. 0.20 times 1 minus 0.20 over sample size 700 and something? 760? 760, and we square root this whole thing. There's the setup, except I'd have a number there. I'd have a Excel equation to find this critical Z, and I'd have a number there, but there's the setup. There's where most of the points are. That's how easy it is to do this quiz by showing me this setup. I don't want to see the equation with variables. I don't want to see the equation with variables on the homework anymore either. I just want to see the numbers where the variables would be. That's what I want to see, that you're plugging in the right numbers where they're supposed to be plugged in. And then you're going to show me 2 steps of algebra at least, and then give me the results. This quiz is going to be so easy if we can remember everything I'm just saying right now, 5 days from now. All right, let's do another. Wait, is this it? Dang. Where is it? Don't tell me I closed it. Oh, here it is. Okay. A homeowner is concerned and wants to know when it is optimal to put their house on the market. Her realtor friend informs her that the last 26 houses have sold in their neighborhood took an average of 218 days to sell. That's a long time, by the way. The realtor also tells them that based on prior experience, the population standard deviation is 72 days. Calculated 95% confidence interval manually, giving me the Excel equation for either C or Z. 1, 2, 3.
1.
Very good. 1. And the reason this is number 1 is because of that one little sentence right there where the realtor also tells them that based on prior experience, the population standard deviation is 72 days. That's how you know it's number 1. Right? All right, let me think here. Are we doing Z or T? Z. What's going to be right here in these parentheses to calculate Z on this problem? 0.975. 0.975. It's 95%. The significance 5%. Half of 5% is 2.5%. Add 2.5 to 95 is 97.5%. 0.975. Get it? You only got to do this when you got to find Z. T is a different story. T, you just put the significance in. If this were a T problem, just pretend for a second. This is hypothetical. What would be the number right there? What? 0.05. 5%, 0.05. Because it's 95% confidence, it's 5% significance. Two-tail, you just put the significance there. Now here's the tough part. I got to stare at this for a minute. I don't know the answer. I now know it. What's the degrees of freedom if, hypothetically, this were a T?
25? No.
Yeah, say it again.
25?
25, there's 25 houses. 26 is the sample size, so 25 would be degrees of freedom. Exactly. All right, you're getting it. Let's do another. Oh my God, this quiz is gonna be easy.
Wait, what's the answer to this?
This one, the answer is number 1, and then I went into a hypothetical as if it's number 2, so it's really not number 2, I just was hypothetical. This is number 1, because it's giving you the population standard deviation, that's how you know it's number 1. Okay, you ready? According to a recent survey, high school girls average 100 text messages daily. Assume, I don't know why you laugh, but assume that the survey was based on a random sample of 36 high school girls. The sample standard deviation is computed to be 10 text messages daily. Calculate the confidence interval of 90% confidence. You give me Excel equation for manually to give me for either Z or T, blah, blah, blah. It says number 1, 2, or 3? 2. Very good. You guys, you're on top of it better than the previous semester. I'd hear maybe 2 or 3 people tell me the answer to this, and then you're almost all telling me. These videos might be working, I'm actually shocked. So the reason this is number 2 is right there, that sentence that says the sample standard deviation is computed to be 10 text messages daily. If you're given the sample, and I want to tell you, it's not so obvious sometimes whether you're being given the population or sample standard deviation. But I think my biggest hint to determine, am I reading something that has the sample or the population standard deviation, is ask yourself, does it clearly say I have the populations? Usually the population standard deviation is much more clear than the samples. And if you can't say to yourself, this is clearly giving me the population standard deviation, then it must be giving you the samples. If you can't, because usually the populations is pretty clear. It's the sample one that's not so clear. You gotta almost read it twice and go, okay, wait, is this standard deviation coming from the sample or is it coming from the population? If you're questioning it, read it again, but ask yourself, is it clearly coming from the population? And usually the answer is no, it must be coming from the sample then. That was it? Okay. All right, so this is number 2. So now that it's number 2, we're looking for Z or T, of course. T. We're looking for T, so let's go to here. T, INV, no dot there. I know that was, it's no dot 2T or something like that. You can use that one if you feel comfortable with it. I want you to start getting used to this one's all. Equals TINV, it's two-tail. What numbers going in those parentheses? Let me stare at this for a minute. Okay, what numbers go in the parentheses? 0.01. 99% confidence means 1% significance. Two-tail says you only use the significance. You don't have to add anything to it. You don't have to double it. So you're putting 0.01 for this problem in here. And degrees of freedom for this problem would be 35. 36 high school girls were in the sample. Subtract 1 gives you 35 as your degrees of freedom. You now found your critical T. I think we need to do a setup on this one. You guys should tell me right off the top of your head, where's our formula for T? For a confidence interval for T, what slide is that formula? 18, I hear. Is that true? It is 18. Look at you. Oh my God. Can't leave it on the NASDAQ. You do not want to test it. You guys are young. Maybe you can handle this. But I want to tell you, I'm turning 63 in a few weeks, and I cannot handle this again. It was bad. It was awful. All right.
What's that?
So you're saying T. So here we go. Help me set this up. Let's look at the formula. You got to have the sample mean. We're going to have our critical T, which we just said. We're putting a 1 in there. Degrees of freedom was whatever that sample size. The girls were -1. Our standard deviation over. So let's do the setup. This is just like a quiz.
X bar.
Here we go.
X bar is 100.
What's the mean?
100.
100. So we're going to go 100 plus and minus. We're going to have our critical T. I'm just putting T for now because we already talked about what would be here. 0.01 would be there, and degrees of freedom would be 35. Then the formula says multiply this times the standard deviation. The sample standard deviation is 10 over the square root of the sample size, which is 36. Oh, look how convenient that is. Square root of 36 is 6. There's the setup. but you're gonna have a number there where t is, and you have an Excel equation showing me how you got that t, there's most of the points. You're passing this if you just do this on that problem, and each of the problems. The setup and the critical value formula, you got almost, you're passing. It doesn't matter if you go any farther here. Matter of fact, if you're worried about time, get this set up, go on to the next problem. You can always do this algebra anytime. You can solve, once you have it set up, you know, okay, now I'm gonna show two calculations. Square root of 36 is 6. 10 divided by 6 is 1 point whatever. There's two calculations shown. Now get to the answers. That's how you get all the points.
Did you just not show the n-1, or
N-1, where's that at?
isn't it,
Oh, no, that just means you, if you were using a T-chart, you would wanna use degrees of freedom on the, N-1's degrees of freedom, but we're not using a T-chart. No T-charts or Z-charts allowed on this quiz. We're using Excel for every critical value that we're finding, we're using Excel. So you just gotta make sure you're entering, the significance there, which is, this problem is 0.01, and degrees of freedom, which is gonna be 35, because the sample size is 36. You don't have to worry about, ignore that on the formula, okay? That's if we were using the chart. How we doing? Oh my God, this quiz. Oh, I can't believe I'm here today. This quiz now, you now realize how easy this is gonna be, right? Oh my God, what a beautiful day. What time is it? How we doing?
Do you have a T?
What time is this class over?
We got time.
3:15, right?
3:15, it's only 2:28? Thanks. She's saying you guys would appreciate getting out early, I think is what she said. Ready? A poll of 1,079 adults found that 51% of the Americans support Arizona's stringent new immigration enforcement law, even though it may lead to racial profiling. Use the sample information to compute a 95% confidence interval for the blah, blah, blah. Give your Excel equation for either Z or T, blah, blah, blah. 1, 2, or 3?
3.
3 it is. No standard deviation there whatsoever. It's a proportion. Matter of fact, you don't even have to calculate the proportion on this one. It literally gave it to you at 51%. So this is gonna now be 0.51 plus or minus critical Z. 0.51, 1 minus 0.51. What was the sample size? Oh, big. 1,079. Boom, there's the setup. It's that easy. Oh my God, this is too easy. Let's find you, what is the numbers? Is 3? Okay, so if we're doing number 3, let's do the Excel equation. All I need to know what goes in the parentheses for the Excel equation to find my critical Z on this one. And, wait a minute, let me stare at this for a minute. This is number 3 though, darn. I wanted to use confidence on one of these. Anyway, let's use, what would be, to find Z, what would go in the parentheses for this problem right here? 0.975. It's 95% confidence. Half the significance would be 2.5% of 5, right? So 95% plus 2.5 is 97.5%, 0.975. Oh, this makes this too easy. Okay, I want to go back though. I want to do one of these. I think that was the last one. Yeah, I want to go back. Let's go to the one before it. I want to pretend now I'm asking you to solve this using Excel only. Do not solve it manually. Do not give me the equation for the critical value. Use Excel equation only in all in one sentence. I want to see that you literally have given it to me all in one sentence. Hang on, let me show you what I mean. Now, I don't have this equation memorized, so right now in my mind I'm forgetting what goes with parentheses. Let's see if you guys can talk me through this. This is going to be one equation you're entering in, and it starts with a 0. Anything you're entering in Excel has to start with an equal sign. Excuse me, not a 0, an equal sign. So there's the equal sign. I'm looking at this problem. Let me stare at it. What's the next number if we're using confidence? What's the next thing that should be after that equal sign? The mean, which is how many? Average is what? 100. Now, I'm just for abbreviation putting plus and minus. One would be a plus, one would be a minus. I don't, on the quiz, you could write it in one sentence and put one plus and minus, but there should be 2 answers. One should be the minus and one should be the plus, but you can write it in one equation as long as you got the plus minus. The next, the next one is the word confidence. Is that it? Am I doing it right? I think I'm making a mistake, aren't I?
Dot T.
Dot T it is, because this is a sample standard deviation. If this were the population standard deviation, it's just confidence. But because it's the sample standard deviation, this is dot T, parentheses. There it is. Now, I'm trying to remember what numbers go in there. Don't tell me, I'm going off the top of my head. But the first number has to either do with significant confidence, I can't remember. The second number has to be with the standard deviation or something. And the third number is either the sample size or the degrees of freedom or something like that. So let's start with the first number. Is it the significance or the confidence? This is a T, so I'm gonna guess it must be the significance probably for the first number. Does that sound right?
Yes.
Yes. So what is the significance of this problem? 0.01. So 0.01, comma. Now if you put 1% there, Excel still reads it. It's still correct. 1 with a percent symbol, Excel knows that's 0.01, so that still works. Comma. Next is the standard deviation. This is a sample standard deviation, so what's the number? 10. Am I correct? It is standard deviation number? Did you look at the number?
Yeah.
Okay. Comma. Now I can't remember if this is degrees of freedom or sample size. Sample size. So what's the sample size in this case? 36. Parentheses?
Yes.
That's it?
Yeah.
Wow, there's a lot of points right there. Now you're gonna give me 2 answers that after you plug this into the Excel on the device you're gonna be using while you're taking the quiz. And that's how easy these problems are. Just like the homework, number 3 from week 1 and week 2, we're both number 3, I think, were where you're using the confidence equations. Oh my gosh, let me take a look. I almost covered everything that I think's on the quiz already. Jeez. Except for sample size. Let's talk about sample size. Any questions on confidence intervals? I just covered all 3 weeks to the point to where you just took an example quiz basically. And you now realize how easy this is gonna be. I'm gonna offer extra, go ahead. Say that, did- right here, is that dot T, is that what you're asking me? Yes, I'm sorry, I can't hear, someone who can hear her, delay up what she said.
TIMV.
This is no dot, is that what she's asking?
Yeah.
Yeah, you can use the dot if you find that one easier, because that was the one I think's in the recorded lecture. But I'm starting from this point to just use the TIMV as gonna be the main one for the critical values. These are the only 2 equations I'm probably gonna talk about for the rest of the semester to find critical value. All right, let's talk about finding the sample size. 2 equations to learn. I gotta find it. Wait, you know what I wanna do before I go to that? I wanna do one of these homework problems. I want you to see how it's done. Because this is gonna be, like this one right here, here we go. I mean, this almost looks like a quiz problem, except a little more story maybe in it, instead of just these few words. All right, let me see here. Let's pretend this is a quiz question, and it's asking you to solve it manually. And since it's asking you to solve it manually, you know it says something like give the Excel equation to find either Z or T, and you got to identify which kind of problem you got here. You already told me this is number 1, 2, or 3.
3.
You said it was 3 because there's no standard deviation at all. So I always start out with, let's find the critical value. So I'm going to start right here, pretending like this is a problem off the quiz. I'm going to go equals NORM, what is it, dot S dot INV, parentheses. It says here if it's true tail, use the confidence plus has significance. So I'm looking at it, 95%. This is going to be 0.975 then, right? And then I wrote it just like that on my quiz. Did I do this already? Right there, norm S. So this ends up being, this equals 1.96. Now, you should go more numbers to the right of the decimal than just 2. Matter of fact, when we get to these proportion problems, you should be going 4 digits to the right of the decimal. 4 digits to the right. And I'll try to remind you of that on the quiz. I just realized now I should put that on the quiz itself. Because I think I put that in today's in-class assignment. Let me look here. Where's today's in-class? Yeah, use 4 digits to the right of the decimal, right there. So on today's in class, it literally tells you to use 4 digits to the right decimal. This is number 3, which is a proportion problem. So here's a perfect example where we should be using at least 4 digits to the right. And the reason we need 4 digits is when you get into the math of this, there's problems that are 0.000 and then a number. You'll never get to the number unless you go at least 4 digits. So that's why we need to go 4 digits on proportion problems. So here it is. I'm pretending like this is a problem off the quiz. I'm writing that out and got my critical value. Now what's next? The setup. This is where the points are at. I look at the formula and I go, oh, okay, here's the formula. We're back, here's the formula right here. There it is for number 3. So I gotta go and I gotta go, okay, what's the given proportion here? Is this proportion? Oh, this isn't proportion. What is this? This is a norm. This
This is
is
another question, you switched it.
I switched it? When did I switch it?
Successive.
But what's the question we were working on then?
Successive?
Think 3, problem 1.
Oh, from the homework?
Yes.
Thank you. Darn. Here we go. Here we go. Now, what is the proportion? Is this doing an interval for successes or failures?
Success.
This one's saying do a 95% confidence interval for successes. Then it says do another confidence interval for failures. It's asking you to do 2 different ones. If this is a quiz problem, I'm never going to ask you to do 2 different proportions, only one of them. Let's pretend it's only asking for the successes. Tell me how to find the proportion of successes. What divided by what?
Divided by
50 divided by 80. Let's read it again. Random sample of 80 observation results in 50 successes. What if instead I was asking, just for the fun of it, the proportion of failures? How would you calculate that? 30 over 80, right? If there's 50 successes, there's got to be 30 failures. So 30 out of 80. But this is asking for successes, so let's stick with that. 50 out of 80. Someone get the math on that. Point what?
65.
0.65.
25.
Oh, 25? 25?
Yes, sir.
25. 0.25. 20. No, that's
No,
not.
no, 0.625.
Oh, 625. Oh my gosh.
Sorry.
0.625. Am I okay now? Is it good? We good, everybody? Is that it? All right, there it is. There's points. We got points finding the proportion. We got points that we got the Excel equation to get our critical here. This is about, I think this is like 3/4 of a point. This is 1/4 of a point to give me this. Then we gotta do the setup where a bunch of points are. 0.625 plus and minus 1.96 times. This is gonna be 0.625 times 1 minus 0.625 over, what's the sample size? 80, there we go. Square root this whole thing. Do not give me a square root just over the top or just a square root over the 80. For this problem, for proportions, it's square rooting this whole thing. This is called the standard error of the proportion. This is called the margin of error, including when you include that. But just this part under this square root is the standard error of the proportion. That part right there. There's the setup. Does it look correct? Now I'm going to show 2 calculations. Then I'm going to show the interval. And that's it. I got all the points. Oh my God, I'm going on to the next problem. This quiz is too easy. I'm going to get done early. Oh, I was given too much time. This thing is so easy. Oh my God, I have to sit there and stare at it just so it doesn't look like I'm some sort of smart. What? Yes.
How would you do that kind of problem in Excel?
Solving it now?
In Excel.
Oh, you mean if I said only use Excel?
Yeah.
Then you'd have to use for proportion, I'm not going to ask that.
Okay.
If it's one of the other two, you would use that confidence or confidence T, depending if you have the population standard deviation or you have the sample standard deviation. So you're either using confidence or confidence T if I'm asking you to use Excel only to solve it. In this case, I'm asking you to solve it manually, but give me the Excel equation to find the critical value in this case.
Yeah.
Go ahead.
Is the sample size, equations up there on the board?
Yeah, we're about to go to those, yeah.
What says error, is that the standard error or the margin of error?
It's the error given to you. It's gonna be given to you. So whatever amount of, it's the amount of error allowable that's gonna be given to you that will then determine what sample size you can, the minimum sample size you can use. There's a hint at the end of that problem too, I'll make sure you realize it. Go ahead, I'm sorry.
When it's asking for successes, is that always proportion C?
oh no, it's a Z only because there's no standard deviation. That's why we're using proportion. The successes is just, you know, it's, I don't even know how to describe it. Instead, it should say, a random sample of every 80 observations resulted in 50 saying yes, they would vote for that policy, or something like that, but the word successes probably won't even be on a test like that. It would be more description of what it really is measuring.
Okay, it won't be on.
Not the word success, it would be 50 something, 50 people, a survey of 80, a random sample of 80 observations and 50 had defects. And then you gotta find the proportion of defects, okay? Okay, does everybody understand how to finish this problem, or I mean, everybody knows you just gotta show me two calculations, maybe like 0.625 times 1 minus 6.25, there's one calculation. Then you take that and divide by 80, there's a second calculation. If you wanna show a third one, square root it and get a third calculation. If you wanna multiply it then times 1.96, there's a fourth calculation. I'm only asking if you show me at least two of the calculations. That's all I'm requiring. Then give me the two intervals. You'll add and subtract the results of all that to 0.625, the upper and lower. So I want you to see here on the answer that I posted, look at what I did. This is successes. P, 50 divided by 80 is 0.625. Then here's my Excel equation, this one I'm using the old one, dot IMV instead of the S, so you got the 0 and 1 there, but still it's 1.96. Now I'm showing a couple calculations here. Here's my whole margin of error setup. The margin of error is to the right of the plus and minus. 1.96 times the 0.625 times 1 minus the 0.625 divided by the 80, square root the whole thing. That's all right there. If you notice, I'm starting to do some math on it. 0.625 times 1 minus 0.625, there's that result, 0.2344. Now look what I did. I took that, divided by 80, look at 0.00293. Sometimes that's 0.000 something something. That's why we gotta go 4 digits. Now I'm gonna take that number, I'm gonna square root it, and now I got 0.0541. Now I'm gonna take that number, multiply it times 1.96. Now I got 0.106. Now I add 0.106 and subtract 0.106 from the 0.625. And there's my interval, 0.519 and 0.731. Does everybody see how I did a proportional interval and how I'm showing at least 2 examples of calculations? So everybody knows what's expected. Good. We are gonna get over it. We got an in-class assignment, but let's get to the part where I wanna show you where we have to figure out the minimum sample size. And to determine the sample size, there's 2 different formulas. One is if you're given a mean with a standard deviation. Don't worry about whether it's populations, sample, whatever. If you're given a mean with a standard deviation, use the left-hand one. If you're given a proportion and no standard deviation, use the right-hand one. There's just 2 examples. The left-hand one, here's the formula. Right here, I put it in words though. The critical Z that you're gonna have to calculate, squared, times the given standard deviation, squared, divided by the given error. You're gonna be given the error, amount of acceptable error, squared, and that gets divided in. All right, here's an example. See? Here we go. The standard deviation is 45. What sample size is needed to estimate the mean plus or minus 5? That's the amount of error right there. We're estimating the mean plus or minus 5, meaning it can go up 5 or down 5. It'll be more clear if this is a problem on the quiz. It will say with the amount of error being plus or minus 5 with 90% confidence. All right, we gotta get that critical Z. Start with the critical Z. Hang on, let me get my pen. It looks like it's 1.645, but how are we gonna calculate that? Well, this is a Z problem. So we're using this top one right here. All I need to know, and this is two-tail. All right, this is two-tail. All I need to know is what number goes in there. It says confidence plus half significance. It's a 90% confidence, so what number will go in our norm.s.imv equation? What number goes there? Oh, come on. Let me ask it again. Ready? It's 90% confidence. We gotta find that critical Z. It's two-tail. What number goes there? 0.9, not 75. 95. It's 90%, the significance is 10%. Half of 10% is 5%, so we add 5 to the 90, makes 0.95. So here's the 0.95 right here. Let me put it up here. I'm gonna switch this to 0.95, and we should get 1.645. There it is, 1.645. There's our Z. That goes right there, and that gets squared. Then, our significance is given to us as a symbol in this one, but if this were a problem on the quiz, it would say, and the, excuse me, the degrees, the standard deviation is equal to 45. So 45 squared, standard deviation is equal to 45. And then the error, it will say, and the amount of error plus or minus 5. That's your denominator, 5 squared. See the setup? Now here's the deal. This calculates to 219.19. When you're calculating the minimum sample size, you must round up. This is the part you need to write down right now so you don't forget it. You must round up. That could have been 219.01, and you got to round up to 220. You get it? Do not use normal rounding. You must round up.
You round up to the whole number?
You round up to the whole number. This could be 219.0001, and you got to go to 220. All right? I want you to see another example. In the homework, let me make sure this is one that's a Z. Is this it? No. Is this it? No. No. Is this a Z or T? Is this a Z? This is a Z. Here we go. Oh, oh, oh. This is it right here. There you go. In the planning stages, oh, this is a proportion. Darn it, this is not the one. What about this one? Is this one? This one's a proportion too? Darn, okay, I can't give you an example. So, I'll just do this one again. Standard deviations being given to you is 45. The amount of errors being given to you is plus or minus 5. And the confidence is 90%, which will allow you to find the critical Z. Now, if this is a proportion, there'll be no standard deviation. Instead, it'll be giving you a proportion. So let's look at that example. Here's the formula for proportion. Again, let's pass it. Right here. The critical Z squared, just like the previous one, and the amount of error squared. Be careful though, this error squared down here has got to be in decimal. In decimal. And then this numerator right-hand side though is not the standard deviation. Instead, it's the given proportion times 1 minus the given proportion. There's the difference. You don't square this either. There's the difference in this formula compared to the other one. So if there's no standard deviation, it's asking you for the sample size. If there's no standard deviation, you know it's this formula. Now here's what it looks like. Whoops. How large of a sample size is necessary to estimate the true proportion of defectiveness, proportion of defects in a large population within plus or minus, there's the error, 3%. Be careful, that must be in a decimal, not 3%, 0.03. That ends up getting squared. 95% confidence, there's how we get our Z. And it says assume a pilot sample yields a proportion of 12%, 0.12. There's the given proportion. So this would be 0.12 times 1 minus 0.12. Down here would be 0.03 squared. And this critical Z would be, what's the confidence? 95%. We're using Z. It's a two-tail, so what number goes here? Not 0.95, but what's your favorite number? 975. That's what goes in there. And then that will give you your Z. So here it is. We find, hey, what are you trying to do? There we go. We find our Z, we plug it in, 1.96. That number gets squared. The given proportion was 12%, 0.12 times 1 minus 0.012. And then the error that was given was 3%, put it in decimal and square it. 450.74, you must round up. 451. There's a quarter of a point off if you don't round up. So there's an extra quarter of a point to show me that you know to round up when you get to the end here. Now, the example on our homework happens to be a proportion, so let's look at that one. Is this it? Yeah, in the planning stages, the sample proportion is estimated to be 80%. There's that part right here. 0.80 times 1 minus 0.80, we got that number. Use the information to compute the minimum sample size required to estimate at 99% confidence. Let's stop there. What number goes right here? 99% confidence. 0.9. Ooh, this is tough. Hang on. 0.90. It's 9. Is it what kind of confidence? 99. We're doing the first one. 99% confidence. What number goes here? 0.995. 995. 99% leaves 1% significance. Half a percent is half of it, so 0.995 goes right there. Oh man, don't let that trick you. I can see some looks in your eyes where you're going, oh, I would not have known that one for some reason. It's the confidence plus half the significance. 1%, half of that's a half a percent, add it to the 99%, 99.5%. We get 0.995 is 2.576. There is our Z, 576 squared. We got that. What was the error? Oh, we have that? Oh, wait, it says, we're desiring the margin of error to be 12%. There it is, 0.12 squared. So we got 0.80 times 1 minus 0.80. We got 2.576. You showed me the equation, how you got that critical Z. That gets squared. And then you took the error that was given to you, which is 0.12, what was the error? 0.12 squared. You're gonna show me at least 2 calculations. There's the setup. You're gonna show me at least 2 calculations. Look at the 2 calculations here. Right there, 21. So I took all of this times this and got 21.4667 squared times 0.16. I don't know, I'd have to go through how I got all these numbers, but you can see I got at least 2 calculations there. Then I multiply it, what's 12 of 0.12 squared? I don't even see where that is. Anyway, I end up with 73.73. I round up to 74. Then I guess I'm asking you to do the same thing at 90% confidence. The only thing it changes in this case is gonna be your Z. Instead of being 2.576, it's gonna be 1.645. And that's about all it changes. All right, you now have all the formulas that we're gonna use for the quiz. 3 proportion formulas, 2 sample size formulas, and my grandmother could do this quiz. That's how easy it is.
She just has a lot of experience.
Who's that, my grandmother? And she's dead, she could do it. Is that it? Is that it? I wanna make sure we're ready to do the in-class assignment. I'll hand back this stuff while you guys are working on the in-class assignment. Just hand them in up there. No one come and shake my hand or nothing. I don't want you to get sick, and I don't want to get sick again either. So, here's the in-class. No, just don't get close to me. Are you ready? Use at least 4 digits to the right of the decimal. That's the first sentence there. A survey of 625 people found 425 respond yes. They wasted money in 2024. That's right. Oh, that's right. This is my pet peeve. People wasting money. I hate it. I hate seeing everybody waste money. And yet everybody wastes money. And at 95% confidence, what's the interval of the population proportion of who have wasted money in 2024? Show your detailed calculations to manually construct this 95% confidence interval for the population. Include your Excel equation to find the critical value. Excuse me. All right. Work with each other. They're sitting around each other to get it started. Then get up and work. You have to compare with 2 other people in 2 different rows other than your own row before you hand it in. Does anybody forget to sign in? I'm going to grab the sign-in sheet. Does anybody still need to sign in? Please sign in real quick. Oh my God. Tia? Tia D? There she is. Alexander? Joe? Alex? Oh, okay. Thank you. Matthew W? Matt, you here? W?
Yeah.
Okay. Trini, T-R-I-N-I. Perfect, alright. Yeah, O-A-Y-A, last name O, up there, got it. Marissa, I.
Okay.
Right, okay, yeah. Where'd she go? Yes, stop the video.